Welcome! This is my third in a three-part series on air conditioners. This video expands on episode 28, how an air conditioner works, to identify the 10 most common air conditioner problems that you're most likely to encounter with your air conditioning system. In addition, I provide you, the do-it-yourselfer, high-level recommendations to fix these problems or make appropriate decisions to hire an HVAC contractor to repair the more difficult air conditioning challenges. In episode 27, I showed how to change a bad air conditioner condenser fan motor and how I saved more than $1,000 doing it by myself in lieu of paying an expensive HVAC contractor to do the job. Episode 28 explains how an air conditioner works to include providing the nomenclatures and functions of its parts, description of its refrigerant, and the applicable portions of the second law of thermodynamics and ideal gas law, which determine its cooling and heat transfer capabilities. For 3.5 years while attending high school in Inglewood, Colorado, I worked for a small family-owned refrigeration and air conditioning company. I worked full-time during 4 summers and continued working on the weekends and school holidays during the school year. I started by cleaning and sweeping the shop and helped deliver repaired refrigerators and air conditioners. Noticing that I was working very hard, the owner taught me the theory of refrigeration and how to troubleshoot and repair refrigerators and air conditioners. Approximately 2 years into the job, I could troubleshoot and repair most of the refrigerators and air conditioners that came into our shop. This included changing motor compressors, silver soldering refrigeration line connections, evacuating refrigeration and air conditioning systems, and charging them with new Freon refrigerant. It was a great job for me as a high school student, and I really appreciated its challenges and responsibilities. Soon thereafter, I received an appointment to West Point. As a cadet, I uniquely looked forward to taking our engineering thermodynamics course because it addressed my high school refrigeration hands-on technical experiences. We studied the thermodynamics theory and design of internal combustion engines, heat engines, turbine engines, diesel engines, and refrigerators and air conditioners. This included the applications of the second law of thermodynamics and the ideal gas law to refrigeration and air conditioning, which I'll soon explain. It's very important that you understand this schematic on how an air conditioner works before continuing. If you have not reviewed episode 28 on how an air conditioner works, I recommend that you do so at this time and then return to this video, episode 29. Throughout my explanations on the 10 most common air conditioner problems, I will frequently refer to the principles on how an air conditioner works. With this background, you will understand the rationale of each of my repair recommendations. In my opinion, this is the most common air conditioning problem that you will encounter. As you can see, my condenser and its coils, fins, and screen are clogged with dirt, debris, bird feathers, and other stuff. In this area, the condenser is experiencing major restrictions of cooling airflow. In fact, I've already experienced this problem twice this year. I thoroughly cleaned the condenser in late May, and it's now mid-August and it's starting to clog up again. It will normally clog in the rear of your air conditioner closest to your house because this is where most of your outside cooling air is pulled through your condenser coil. This degree of clogging will not ruin your air conditioner. However, it will significantly increase your electric bill because your air conditioner has to run longer to dissipate your home's heat energy to the outside surrounding air. In addition, your system must start up more often to keep your house cool, so it causes additional wear and tear on your capacitor here in the condenser unit and the capacitor which starts your heater blower motor. Worst of all, severe clogging of a condenser can cause your motor compressor to overheat and burn up its windings. The solution to this problem is to simply clean your condenser coils 2 or 3 times a year. However, it's important you clean it properly. I strongly recommend against using a motorized pressure washer because its powerful stream of water will bend your condenser's delicate aluminum fins, which will also restrict your cooling air through your condenser. I recommend that you use a standard garden hose and possibly a brush with very soft bristles. You can clean it best by removing the fan shroud on top of the condenser, but frequent removing and installing these mounting bolts will damage their sheet metal holes and cause you major problems with this structure coming loose. Consequently, I strongly recommend against that also. Using your garden hose, I recommend that you clean the condenser by starting at the top of the coil and spraying and cleaning with a downward motion until all of the dirt and debris are gone. The solution to this problem is the simple fix I just described, so I'm rating it as an easy do-it-yourself task. However, as I emphasize, this is a very important task which is critical to keeping your air conditioning system running. Similar to a dirty and clogged condenser coil, a dirty furnace air filter can cause you major problems. It will also cause your air conditioner to run excessively to achieve the cooling level set on your thermostat and result in high electric bills and major wear and tear on your air conditioner, motor compressor, condenser fan motor, and heater fan motor, as well as your condenser capacitor and your furnace blower motor capacitor. When changing the filter, ensure that you install it with the arrow printed on the filter corresponding to the direction of airflow. To keep track of my filter changes, I mark the month and date I replaced it here next to the filter to ensure that I don't forget to change it annually. To make this easy, I normally purchase a 2-pack of these filters from Home Depot and store them on a shelf near the furnace. Similar to problem 1, annually changing a dirty furnace filter is an easy do-it-yourself task. If you notice water leaking from the base of your evaporator drain pan and no water coming out of your drain hose, you most likely have a clogged evaporator drain line or blocked fitting connection. Consequently, I recommend that you remove the line and clean it. I also recommend that you clean out its fitting and clean the visible dirt, mold, and rust from the drain pan. Be careful not to damage the evaporator. It's a very expensive part of your air conditioning system. This, in my opinion, is a very easy do-it-yourself task. Most municipality building codes require a furnace switch close to the unit, so it can quickly be turned off for safety purposes. While changing your furnace filter or cleaning around your furnace, it's possible that you could inadvertently turn the switch off, or one of your kids may turn it off while playing in the basement. If this happens, neither your furnace or your air conditioner unit will work. If your air conditioning system will not come on, check this switch to ensure that it is on. This is also an easy do-it-yourself task. If you can hear your air conditioning system come on and both the condenser fan motor and motor compressor try and fail to start with buzzing or humming sounds, you most likely have a bad capacitor. Most air conditioners use the same capacitor to start the fan motor and motor compressor, so if both fail to start, the problem is most likely the capacitor. It's critical that you're careful with this 230 volt system. If you improperly cross or touch two terminals with a metal object, such as your screwdriver, you could burn up the entire system or seriously injure yourself. Step 1 is to remove the major circuit breaker or power disconnect from the black box adjacent to the air conditioner condenser. We'll now remove the electrical access panel's screws. And remove the access panel itself. Set it over here. My capacitor is here on the left side of the access panel. It's important to mark each of its 3 electrical wires. Next, loosen its mounting bracket and remove the actual capacitor. Okay, so I have the capacitor, my jarred capacitor over here on the patio table. And at this time I'm going to short across its terminals. As you can barely see, this is the common terminal, this is the HERM terminal, and for some reason, I guess this is fan. It's very hard to see. It's not very well stamped. So this has to be the fan. Okay, so we've got common, HERM, fan. So we want to short between common and HERM with a long bladed insulated screwdriver. So common to HERM, we shorted, no problem there. And common over to fan, and we had no spark there. So this is actually safe to work with at this time. Since this is a good capacitor, I'm going to put it back in. As you can see, it's not swollen on the top or the bottom, so we've appeared to be a good capacitor. Based on my experience, you can expect your outside condenser capacitor to fail every 5 to 10 years. A bad capacitor is one of the most common air conditioner failures. Your capacitor will most likely fail during the summer, and you'll have to wait 1 or 2 days for an HVAC contractor to arrive to troubleshoot and replace the capacitor. Consequently, I recommend that you purchase a spare capacitor and store it in your basement or garage so you can immediately replace the capacitor yourself for approximately $20 to $30, as opposed to having to wait 1 or 2 days for an HVAC contractor to replace it for $200 to $400. This is the blow-up picture of my capacitor's data plate. This is its part number. If you can get the same part number, that's good, but it's not critical that your replacement has the same part number. In fact, in many cases, you will not be able to get a replacement with that part number. However, it's critical that these three numbers on your replacement match these numbers on your old capacitor. In my case, the important data plate numbers are as follows: 45 μF, 5 μF, and 440/370 volts of AC power. Sometimes these will appear on a data plate as 45 MFD or 5 MFD. In both cases, this means 45 microfarads and 5 microfarads of capacitance. 45 microfarads is the capacitance charge for the motor compressor in the bottom center of the condenser, and 5 microfarads is the charge for the fan motor. The plus and minus 6% accuracy tolerance is measured by a multimeter with a capacitance capability. The third important number is 440/370 VAC, or 440 or 370 volts of AC power. In many cases, this will be designated as 370 or 440 VAC on a data plate. Please note that if you have a 370 VAC capacitor, you can always move up to a 440 VAC capacitor. However, if you have a 440 VAC, you cannot move down to a 370. If these three numbers on your new replacement capacitor data plate do not match your old capacitor's numbers, do not attempt to install it. If your capacitor is old and its data plate is not readable, I recommend that you call an HVAC contractor. In addition, at any time if you feel uncomfortable about replacing your capacitor, I strongly recommend you call an HVAC contractor. When replacing the capacitor, disconnect and move the wires one at a time and move them to your new capacitor using the markings that you captured when removing the bad capacitor. It's possible to test your capacitor if you have a multimeter with a capacitance capability. I have a good meter, but it doesn't measure capacitance. I've seen meters with capacitance capabilities for sale in the $60 to $80 range. However, in this case, when neither the fan motor or the motor compressor starts, and you can hear them trying to start with a humming sound, you can be fairly sure that the problem is a $20 capacitor. Consequently, I have opted not to buy an $80 multimeter to fix a $20 problem. I would rate this as a medium level difficulty task for the do-it-yourselfer who is comfortable working with electrical circuits and components. However, for the inexperienced electrical folks, I'm rating this as a difficult task that requires an HVAC contractor. If your outside air conditioner condenser compressor runs but your fan motor has a loud scraping sound, your fan motor bearing is most likely bad. In addition, if your fan motor does not turn at all or only turns for a minute or so, it is also most likely bad. If you are experiencing this problem, I recommend that you review my Let's Fix It Right episode 27, which shows you step by step how I save more than $1,000 replacing a fan motor by myself. This is a medium level of difficulty task for the do-it-yourselfer who is comfortable working with electrical circuits and components. For the unexperienced electrical folks, it's a difficult task that requires an HVAC contractor. If your furnace squirrel cage blower motor in the lower compartment of your heater makes noise or will not run, it could be the blower motor or the blower motor's capacitor. In my opinion, the furnace blower motor and condenser on the left are more difficult to access, troubleshoot, and repair than the less complex condenser fan motor and capacitor installation on the right. Considering the potential for you to damage something while trying to repair or replace a blower motor, I recommend that you refrain from working on this motor if you have not done this before. Consequently, I'm rating this as a difficult task that requires an HVAC contractor. As I mentioned in episode 28, your air conditioner is a sealed system that is charged with a proper amount of R410 refrigerant, liquid, and gas. If a significant amount of this refrigerant leaks out of the system, your air conditioner will not cool. It's possible that you could have a leak outside here in the condenser or inside in your evaporator or any of the line joints carrying the refrigerant. Frequently when you're low on refrigerant, the evaporator coil inside will freeze over. If you have a slow leak, an HVAC technician can refill it, but if he does not repair the leak, it will leak out again over time and your AC will eventually fail to cool again. In addition, an HVAC technician can load dye into your system to determine where the leak is coming from and in some cases permanently repair the leak. The majority of leaks occur in the evaporator, which normally needs to be replaced because the evaporator joints where leaks occur are extremely difficult to solder. Consequently, this is a very expensive leak requiring a new evaporator and a new charge of R410 refrigerant. In many cases, people opt to purchase a new air conditioning system instead of making a repair. I rate this as a difficult task that requires an HVAC contractor with special refrigeration tools and equipment and experience beyond the typical do-it-yourselfer. Considering this is an expensive repair, I recommend that you get 2 or 3 quotes from different HVAC contractors. If your outside condenser fan runs, but your motor compressor mounted inside your condenser will not run and possibly kicks the circuit breaker off, your compressor could be bad. Similar to an evaporator leak, a bad compressor is a major problem. In many cases, people opt to purchase a new air conditioning system altogether. Consequently, I'm rating this as a difficult task that requires an HVAC contractor. I also recommend that you get 2 or 3 quotes from different HVAC contractors because the repair or replacement of your system is going to be expensive. If your system simply does not run, this could be a multitude of problems to include a bad thermostat batteries, a broken wire inside your condenser electrical panel, a broken wire connecting to your compressor due to vibrations, a bad control board, a bad AC disconnect fuse, etc. Considering that this could require a lot of troubleshooting and parts changing beyond the capabilities of the standard do-it-yourselfer, I'm rating this as a difficult problem that requires an HVAC contractor to fix. This concludes this episode on the 10 most common air conditioner problems that you're most likely to encounter. Don't forget to subscribe to my channel and select the YouTube bell so YouTube will notify you of all my new projects immediately after I publish them. At this time, I'm moving on to my next project. You're more than welcome to follow. In addition, if you have a great project that you want to post on my YouTube channel, email me some pictures and a brief description of it. If it qualifies for the Let's Fix It Right standards to help others, I'll interview you over the phone as a guest do-it-yourselfer, produce a high-quality video, and post it on my Let's Fix It Right channel. For the year following this posting, I'll share 50% of the potential YouTube benefits with you. If you have any subject matter requests or recommendations, please contact me. All of this said, I recommend that you subscribe to my channel, follow my projects, and save a bundle of money doing it.